Hey, what is up guys? Welcome to another video. In this video I'll be going through practice set 7 paper 2 of the higher specification. It should take you about an hour and 30 minutes to complete, and it is a calculator paper. I'll link the paper in the description if you want to have a go yourself, along with the mark scheme if you want to check your answers without having to go through the whole video. So let's get straight into the questions. Question 1 says m equals 3x squared minus nx. Work out the value of m when x equals minus 2 and n equals 5. So this is a pretty simple substitution question where you have to substitute some values in for some letters in the equation. So we're told x equals minus 2 and n equals 5. So where I start with these types of questions is just to write out the equation again with the substituted values in the equation. So I'm just writing out the whole equation again, but when I get to x, take the value of x, which is minus 2, and I usually put brackets around it just to show what change I've made. You don't really need to put brackets, but well, actually you do here because it's a negative. So you're squaring a negative, so you do need brackets around there. And then n is 5, so I need to write down 5 for n, and then that's multiplied by x, which is minus 2. Okay, so I've just written out the equation again with the values substituted in. And now we just need to go ahead and solve this to work out the value of m. So now remember BIDMAS, you need to do your order of operations in the correct order, and the first thing here is the exponent, so I need to square this minus 2. So minus 2 squared, that's 4, and then I can go ahead and do the multiplications. So this is going to be 3 times 4, which is 12, and then this becomes a minus 5 multiplied by minus 2. And so two negatives there make a positive, so this is actually going to be positive 10, and then I end up with 12 plus 10, which is 22, so m equals 22. Question 2 says mortar mix is made by mixing cement, sand and quicklime in the ratio 1 to 2 to 3. Work out the volume of sand needed to make 2.1 meters cubed of mortar mix. So the total amount of mortar mix we need is 2.1 meters cubed, and there are how many parts in this ratio? Well, there's 1 plus 2 plus 3 parts, so there's 6 parts in total of the ratio. So we have 6 parts of that ratio, and that'll equal 2.1 meters cubed of mortar mix. For the sand, that represents the 2 in this ratio because we have cement, sand and quicklime in that order, so there's 1 part cement, 2 parts sand and 3 parts quicklime. So we want to know how much 2 parts of this ratio is equal, and so we can divide both of these by 3. So we're dividing by 3 to get 2 parts, and so 2.1 divided by 3, that's almost like 21 divided by 3, which is 7. So 2.1 divided by 3 will be 0.7. So we need 0.7 meters cubed of sand to make 2.1 meters cubed of mortar mix. Second part of this question says Julie has 0.75 meters cubed of quicklime. She has plenty of sand and cement. Work out the greatest volume of mortar mix she could make. So have a look back at the ratio again. The quicklime was the 3 parts in this ratio. So if we say that 3 parts equals 0.75 of this mix, then one part will be 0.75 divided by 3, that's 25. So 0.75 divided by 3, that'll be 0.25. So one part of this ratio is 0.25. Therefore, we need 0. Now have a look at the ratio again. 1 to 2 to 3. We want 1 part of cement, which is 0.25, plus 2 parts of sand, which is 2 lots of 0.25, so that's 0.5, and then 3 parts of quicklime, which was, we already know how much that is, so that's 0.75. And now we have how much in total we need, so we just need to add these up, and that's going to be, well, 0.75 plus 0.25, that's 1, plus 0.5, that's 1.5. So in total we can make 1.5 cubic meters of mortar mix. Question 3 gives us a diagram and it says in the isosceles triangle ABC, AB equals AC, angle B equals 3x plus 32 degrees, angle C equals 87 minus 2x degrees, work out the value of x, you must show your working. Okay, so hopefully you all know that in an isosceles triangle, the two sides are equal and also the two base angles are equal. So that fact allows us to create an equation here with one unknown. So we can say that because the base angles are equal, we can say 3x plus 32 equals 87 minus 2x. Okay, and then so now we just need to solve this for x. So we could bring this minus 2x over to the left hand side. So add it to the left hand side, so we'll get 5x on the left hand side and then 87 minus 32 on the right hand side. 87 minus 32, that's 55, and then we divide both sides by 5 and we get x equal to 11. So that's all we need to do, work out the value of x, so x equals 11. Question 4a says calculate the exact value of 27.25 squared minus 12.75 squared divided by 0.75 minus 0.25. Okay, so we can just get our calculator out and put that straight into a calculator, making sure we get all of the brackets in the right place. Now, what I'd suggest for this question is because there's a line there, you'd either put it in as a fraction or you can just put brackets around this and then put a division sign. And I generally find that's easier because it's just easier to put into a calculator. So I'm going to put two brackets and then 27.25 bracket squared minus bracket 12.75 squared, and then the brackets again. So those big brackets are containing that top line, and then I can just say divided by, and then put the bottom in brackets as well. So you can, as I said, you can write it in as a fraction or you can just use brackets and it's just as good. So making sure everything's in the right place and then equals, and I get 1160. Okay, so part B says write your answer to A in standard form. Okay, so in standard form we need the first number to be between 1 and 10. So that'll be 1.16, and I can ignore that 0. And so what I've done there is divided by 1,000, so I need to multiply this number by 1,000. And remember, 1,000 as a power of 10, that would be 10 to the power of 3. So this can be written as 1.16 times 10 to the power of 3 in standard form. Part C says write your answer to part A to two significant figures. Okay, so these are the first two significant figures here. And we want to look at the next number after the first two significant figures, the 6. Is it 5 or more? Yes, it is. So I need to round up that second significant figure by 1. So I'm going to get 1200, and the rest of the numbers become 0. So look at the next number. Is it 5 or more? Yes. So add 1 to the number before it, and then the rest of the numbers become 0, and I get 1200. Question 5 says 3 bags of counters are used in a game. At the start of the game, bag A contains 5 red counters and 4 white counters. Bag B contains 4 red counters and 1 white counter. Bag C contains 3 red counters and 3 white counters. The game begins by taking at random a counter from bag A. If the counter is red, a counter is then taken at random from bag B. If the counter taken from bag A is white, a counter is taken at random from bag C. Okay, and then part A says complete the probability tree diagram. So we have some gaps in this tree diagram we need to fill in. So firstly, we need to look at the probability of picking a red or a white. So they've given us the one for red, it's 5 out of 9. So that's out of this bag. So the probability of white must be 4 out of 9. 4 out of 9. And then if the first counter is red, we pick from bag B. So now the probability of a counter out of bag B being red will be 4 out of 5. And the probability of a white will be 1 out of 5. And if our first pick was a white counter, then we pick from bag C, and the probability of the counters being red or white is equal here because we've got 3 red and 3 white, and that'll be a half for each one. So you could write 3 out of 6 or 1/2 is fine. So 3 out of 6 or whichever answer you want to put is fine, and 1/2 for white. Okay, part B says show that the probability that the second counter taken is red is twice the probability that the second counter taken is white. Okay, so we want the probability, and I'm going to use notation here where P is representing probability, and we want the probability of, now what are the different ways of getting a red on the second pick? So we could pick a red and then a red, or a white and then a red. So we could have red, then red, or white, then red. They're the two ways of getting a red on the second pick. So what's the probability of getting a red and then a red? Well, that's 5 out of 9 multiplied by 4 out of 5. So when we have one thing, one event, and the second event, we multiply. So that'll be 5 out of 9 multiplied by 4 out of 5. And then we have or, so when you have or in probability, then we add. We could have a white and then a red. So that's 4 out of 9, a half. So 4 out of 9 multiplied by a half. So now we need to go ahead and solve this probability. So when we multiply fractions, we can use cancelling. So here I have a 5 in the denominator and in the numerator, so I can cancel those, they become 1. So this just becomes 4 out of 9, and this, I have a 2 in the denominator and a 4 in the numerator, so that can cancel to 1, this can cancel to 2, so this becomes 2 out of 9. So what I end up with here is 4 out of 9 plus 2 out of 9. And remember, you can only do that when you're multiplying fractions. You cannot cancel when you're adding fractions. So we have the same denominator here, a 9, so I can add the top line. So this is going to be 6 out of 9, which will equal, if we simplify that, that's 2 out of 3. So I've just divided both by 3 there. So the probability of getting a red on the second pick is 2 out of 3. And the only other possibility is to get a white on the second pick. So the probability of those two events must add up to 1. So we can say that the probability of getting a white on the second pick, white, must be 1 minus 2 on 3. So that will be 1/3. And so we can see that, and they've asked us to show that the probability that the second counter taken is red is twice the probability that the second counter taker is white. So 2 out of 3 is twice. 2 out of 3 is twice 1/3. So there you go. We've shown that the probability that the second counter taken is red is twice the probability that the second counter taken is white. Question 6a says factorize x squared minus 16. Well, basically you can factorize this into 2 brackets. This is just like a quadratic. And well, the first term is x because it has to make x squared, and then inside the brackets we have a plus and a minus the square root of the second number. So that's how you factorize squared numbers like this, because if you expand this out, the minus 4x and the plus 4x cancel themselves, and the plus 4 and the minus 4 become minus 16. So that's your answer for that one. Part B says factorize 9x squared minus 6x plus 1. Okay, so again we have to factorize into 2 brackets. And well, if we have 3x and 3x, we need to multiply those by something to make minus 6x, and we need two factors of 1. Well, the only factors of 1 are 1 and 1. So if this is going to factorize into two brackets, we are going to have to use 1 and 1, and then well, the only way we can multiply 3x and 3x to make minus 6x is if they're multiplied by minus 1. So this factorizes into 3x minus 1, 3x minus 1. And then part C says simplify 6x squared plus 7x minus 3 divided by 9x squared minus 6x plus 1. And you'll notice that denominator there is the same as part B. So we've already factorized the denominator, we just have to factorize the numerator. Firstly, the coefficient of x squared is 6. So two factors of 6 are 2 and 3. And then we need two factors of 3, and they need to work out so that they all make a factor of 7. And well, the only two factors of 3 are 3 and 1. And if we multiply 3 by 3, we get 9. And 2 by 1, and we get 2. And how do we make plus 7 with 9 and 2? Well, 9 minus 2 makes 7, so this has to be a minus 1. So that can factorize into two brackets, where the first term is 2x and 3x, and the next terms are minus 1 and plus 3. And we've already factorized the bottom line, as I said. That's 3x minus 1 and 3x minus 1. And now you just need to look at what you can cancel. So here we've got a 3x minus 1 on the top line and 3x minus 1 on the bottom line. So they cancel out, and we're just left with 2x plus 3 over 3x minus 1. Question 7 says the diagram shows a sector of a circle of radius 7 centimeters. Work out the length of arc AB. Give your answer correct to three significant figures. So here you need to know how to find the arc length, and well, you need to know how to find the circumference of a circle, because the arc length is just a fraction of the length or circumference of a circle. So you take the circumference of a circle, 2 pi r, that's the whole circle, the distance around the whole circle, and then you just take the fraction of the circle you're looking at, and to find that you take the angle at the center. So let's just call that theta in this formula, divided by 360. So that's the formula for an arc length, and then we just have to substitute in the values they've given us. So here we've got 7 for the radius, so this is going to be 2 pi times 7, and multiply that by 40 over 360. And rather than simplify any of that, let's just put it straight into a calculator. So we've got 2 pi, there should be a pi button somewhere on your calculator that you have to press shift to get. Multiply that by 7, and then brackets 40 divided by 360, and equals, and you might get it in this fraction form, and you just have to press the SD button to get it in decimal form, and we get 4.8869. 4.8869, and we need that to three significant figures. So these are the first three significant figures. We look at the next number to see if we have to round it up. Is that number 5 or more? Yes, it is, so we need to round that 8 up to a 9. So to three significant figures, this is going to be 4.89. Question 8 says the fraction P of an adult's dose of medicine which should be given to a child who weighs W kilograms is given by the formula P equals 3W plus 20 divided by 200. Use the formula P equals 3W plus 20 over 200 to find the weight of a child whose dose is the same as an adult's dose. Okay, so the working out for this question isn't difficult. What the difficult part is to work out the first step. So how do you get started on this question? And the key is to carefully read the question. So this fraction P is the fraction of a dose for a child. So we could say something like the adult's dose multiplied by P will give us the child's dose. Okay, so that's the fraction of the dose of an adult's dose that will give you the child's dose. So how can we make it so that the child's dose is the same as the adult's dose? In other words, in this equation, this adult's dose needs to be the same as the child's dose. So how can we make this equal? Well, the only option is if P equals 1. So P must equal 1 for those two things to be equal. So that's your starting point for this question. So we can say that P equals 1 when doses are equal. And then we can make this equation equal to 1. So 3W plus 20 divided by 200 equals 1. And then we just go ahead and solve this for W. So we multiply by 200 on the right hand side. So then we get 3W plus 20 equals 200. I'm running out of room. And then 3W equals now minus the 20 from the right hand side. So 3W equals 180. So therefore W must equal 180 divided by 3, which is going to be 60. So the weight of the child for that to be equal to the adult's dose will be 60 kilograms. Question 9 says the graph of y equals f of x is drawn on the grid. And here we have the graph of a quadratic, some kind of quadratic. And it says, write down the coordinates of the turning point of the graph. So the turning point, hopefully, even if you didn't really know or you'd never seen this before, turning point, hopefully you can just see, well, it must be where the graph turns. So it's going up and up and up, and then it starts going down. So right at the top here is the turning point. And the coordinates of that point are 1 on the x-axis and 4 on the y-axis. So it's 1, 4. And part B, this actually has a typo in it. The mark scheme and the paper are differing on what the answer should be here. And I've seen this paper handed out, and it's actually on the printed paper, it's f of x equals 2. So I think this may be an earlier copy where they've made a typo and they haven't fixed it. So this should either be f of x equals 2, or if it is f of x equals 0, then the mark scheme is wrong. But I'm going to say that's a typo, so we need to find the roots when f of x equals 2. And that basically means if you draw a line at 2 on the y-axis, so where does this graph equal 2 for the y value? That's basically what it's saying. And then we can just find the points where the graph cuts this line at y equals 2. And well, let's go down to the x-axis. So it's about here. So the scale on this graph is 0.1 for every line. So 0.1, 0.2, 0.3, 0.4. That's going to be negative 0.4. And here it crosses again. And that's going to be about 2.4. So when f of x equals 2, x equals minus 0.4 and 2.4. Part C says write down the value of f of 0.5. So that's saying when x equals 0.5. Remember when we usually write it, it's f of x. So they've just put a 0.5 where the x is. So we need to find where x equals 0.5 on this graph. So that's going to be 1, 2, 3, 4, 5. It's going to be here. We need to go straight up to the graph and find the value of y when x equals 0.5. And well, we don't really get an exact value. I'd say it's somewhere between 3.7 and 3.8. And you could put 3.7 or 3.8 or 3.75. Anywhere in between there is fine. Question 10a says 3 out of 10 of the members of a tennis club are men. 5 out of 6 of these men are right-handed. Work out the fraction of the members of the tennis club who are right-handed men. So we have 3 out of 10 who are men, and we want 5 out of 6 of those. So when you have fractions and you're saying something like, well, let's say we had 10 people and we want half of those. So we'd say a half of 10, in other words, 10 times a half. So when you say a fraction of something, you multiply those fractions. So you've got 3 out of 10 multiplied by 5 over 6 here. And we can do some cancelling. So I can cancel this 10 with this 5 because I'm multiplying the fractions. Remember, you can't do this if you're adding fractions, but if you're multiplying, you can do this cancelling. And that 5 becomes 1, and that 10 becomes 2. And I also can do it with the 3 and the 6. So that 3 becomes 1, that 6 becomes 2. So all I end up with is 1 over 2 times 1 over 2, which equals a quarter. So the fraction of men that are right-handed is 1/4. Part B says 7 out of 12 of the members of the badminton club are women. 3 out of 8 of the members of the badminton club wear glasses. Work out the smallest possible number of members of the badminton club. Okay, so for this, you need to think that we're talking about people. So we can't have a fraction of a person. So we need a whole number amount of people. So we have basically 3 out of 8 have glasses. And 7 out of 12 are women. So they couldn't be 8 people in there could not be 8 people in the club, because then this fraction would not give a whole number. So 7 out of 12 of 8 is not a whole number. Similarly, we couldn't have 12 people in the club because 3 out of 8 of 12 people is not a whole number either. So what we want is the lowest common multiple of 8 and 12. So what's the lowest whole number that 8 and 12 goes into? And well, hopefully you can see it without too much working out. 8 goes into 24 3 times and 12 goes into 24 twice. So hopefully you can see that that's 24. There's not a lower number that they both go into. So the smallest possible number of members of the badminton club is 24. Question 11 says, solve 2y plus 1 over 3 equals y minus 2 over 4. You must show you're working. So hopefully you're comfortable with these types of algebraic fraction questions. This is a pretty typical kind of textbook question. So the first thing you have to do is cross multiply to get rid of those fractions. So you multiply this side by 3 and you multiply this side by 4. So the next line, if you're working, looks like this: 4 multiplied by 2y plus 1 equals 3 multiplied by y minus 2. Okay, and then we need to expand the brackets out, and then we can end up solving for y. So expanding these brackets out, 4 times 2y is 8y, 4 times 1, that's 4, and then 3 times y is 3y, and 3 times minus 2 is minus 6. And then I want all of the y's on the left hand side and all of the numbers on the right hand side. So I subtract 3y from the left hand side, and 8y minus 3y is 5y, and then minus 6 minus 4, that's going to be minus 10. And then divide both sides by 5 and I get y equal to minus 2. Okay. Question 12 says the line with equation y equals 2x is drawn on the grid. On the same grid, draw the line with the equation 4x plus 3y equals 12. Okay, so depending on how comfortable we are with graphing lines, you might want this in slope-intercept form. Slope-intercept form is where it looks like this: y equals mx plus c, where the m represents the gradient and the c represents the y-intercept. So the first thing I'm going to do is to get rid of that coefficient of y, or in other words, divide everything by 3, so then I just have y by itself. So if I divide everything by 3 in this equation, I'll get 4 over 3x plus y equals 4. And then, so therefore y equals minus 4 over 3x plus 4. Okay, so now it's in slope-intercept form. What I can actually do is graph this using this equation. So the plus 4 is a y-intercept, so that's where I'm going to start. And then I need one more point, and then I can graph the line. So if the slope is minus 4 over 3, I can go down 4 and across 3. So remember, the slope or the gradient is the rise over the run, so I've gone down 4 and across 3. And I've got 2 points in the line now, so I can go ahead and graph this line. And it should look something like that. Okay, so the next part of this question says, show by shading on the graph the region defined by all 4 inequalities. Okay, so the first inequality is y is less than or equal to 2x. Okay, so they've given us this line y equals 2x. That was here. And we need the region underneath that line, because this, when it says less than or equal to, that's underneath. So this is above the line up here as y gets bigger, and this is below the line as y gets smaller. So we're going to need the region below that line. And because they've given us a number of inequalities, don't go ahead and shade this whole graph in. Just what I would suggest is doing a slight shading like this to represent underneath that line, and then go ahead and do the rest of the inequalities, and you might want to rub some of that out later. So because we need the region that satisfies all of these inequalities. Now we also need 4x plus 3y is less than or equal to 12. And if you rearrange this inequality, you actually get the same as this equation up here. So what this is really saying is when y is less than or equal to this line that we've drawn. Now we need to consider both of these inequalities. So we already know it must be below this line, y equals 2x, and now we know it also must be below this line, y equals minus 4 over 3x plus 4. So it can't be anywhere up here, so it must be down here somewhere. So again, just shade in a little bit, not the whole thing, and go back and rub this out, because we don't need that anymore. It must be below both of these lines. Then we also need y is greater than or equal to minus 3. So we need to go ahead and draw in another line on this graph at y equals minus 3. So that's going to be here. So this is y equals minus 3. A horizontal line at minus 3. And we need it to be, y is greater than or equal to that line. Okay, so greater than means above the line, so shade in this little bit here. Okay, so you can see we've already got a triangle that we might have to shade in, but we have one more inequality to look at, so we don't need this bit down here, and then, or this bit. And then we have one last thing to look at. X is less than or equal to 4. So we need to draw in the line of x equals 4, and that's a vertical line at 4 on the x-axis. So this is x equals 4, and we need all of the x values less than that line, so that's going this way. Okay, so that's in here. So you can see the region that we need to shade in now that satisfies all of these inequalities. That is in here. So go ahead and shade that in, and rub the rest out if you've got any marks left over. Okay, so that's the region that you need shaded there for that question. Okay, question 13 says, given that c is positive, make c the subject of a equals the square root of 1 minus b squared over c squared. Okay, so the first thing in this formula to get c by itself is that I want to square both sides to get rid of this square root sign. So if I square both sides, I'll end up with a squared equals 1 minus b squared on c squared. So that gets rid of that square root sign. And then I want to get rid of this fraction. So how do I get rid of that fraction? I have to multiply everything by c squared. Okay, so if I multiply everything by c squared, I'll end up with c squared a squared equals c squared. 1 times c squared is c squared, and then minus b squared. And because I multiplied this fraction by c squared. So I haven't changed anything, I've just multiplied the whole thing by c squared. which I can do because I multiply both sides by the same thing, and it's still equal. Okay, so now I want all of the c values on the same side of the equation, and what I'm going to do is actually to bring this over to this side and the minus b over to this side, just to make it a little bit easier for myself. So on my next line I get c squared minus c squared a squared, so I've subtracted that whole term from this side, and I plus b squared to the left hand side. Okay, and now I can factor the right hand side. Can you see a common factor here? The common factor is c squared, so I take c squared out of both terms and I end up with 1 minus a squared in the brackets, and I've still got this b squared on the left hand side. And then I'm going to flip the whole thing around, so I end up with c squared on the left hand side, and I divide b squared by 1 minus a squared to get c by itself. So on the right hand side I'll get b squared 1 minus a squared, and the last thing I need to get rid of is this exponent here, this squared, and I can square root both sides to get rid of that. So if I take the square root of both sides, I'll end up with c equal to the square root of b squared divided by 1 minus a squared. And somebody asked me a really good question in one of my other videos about whether to include the plus or minus in these types of questions when there's a square root. And I think you should include it in this question, but they've told us that c is positive, so there can only be a positive value for c. If it didn't tell us that, maybe we should include the plus or minus before the square root. But in this case we don't have to, so c is equal to the square root of b squared divided by 1 minus a squared. Question 14 says Alison is using the quadratic formula to solve a quadratic equation. She substitutes values into the formula and correctly gets x equals minus 7 plus or minus the square root of 49 minus 32 divided by 4. Work out the quadratic equation that Alison is solving. Give your answer in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. Okay, so for this question you need to know the quadratic formula, and I think you need that memorized. So x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. So that's the quadratic formula, and as you can see in this equation we've got a, b, and c. So we just need to use that formula to work out what those letters are in this equation here. So clearly b equals 7, so we already know b because she's written 7 here where the b is in this formula, and 49 is b squared, and then we've got 4ac, and let's just leave that for a minute because we need to figure out what a is first. So if the bottom line on her equation is 4 and in this equation it's 2a, a must equal 2. So 2 times 2 is 4, so a must equal 2, and then we can go ahead and work out what c equals. So 4ac equals 32. That's going to be like 4 times 2 times c equals 32. So 8 times c is 32, so c must equal 4 there. So now we have a, b, and c, and we just need to write that out in this formula. So that's going to be 2x squared plus 7x plus 4 equals 0 for that equation in that form. Question 15 says, here is a speed-time graph for a car. Work out an estimate for the distance the car traveled in the first 6 seconds. For a speed-time graph, to work out the distance, you need the area under the graph, and we need it for the first 6 seconds. So we need the area from 0 to 6, so this area in here. And what they usually want you to do is to split it up into 3 different sections. So we have a triangle here, then a trapezium, and then another trapezium. So we need the area of those 3. So if we look at this triangle, the base is 2 and the height If we look at this scale carefully, this is 1, 2, 3, 4, 5. So every 2 squares is worth 1 unit. So it's going to be 2. So the height of this triangle is 2. The base is 2. So the area is going to be 2 times 2 divided by 2. The height times the base divided by 2. That's going to be 2. So the area of that triangle is 2. Then the area of this trapezium is the top side plus the bottom. So the top is 2 plus the bottom of it, the base is 5. And then we multiply that by the height, which is 2, and we divide all of that by 2. That's the area of a trapezium formula. So if we work that out, well, the 2's cancel, and we're just left with 7. And then we need the area of this part here. So the length of the top side is 5 plus the base, which is 9. If we go across to the y-axis, we get 9. So 5 plus 9 multiplied by the height, which again is 2, divided by 2. So again, those 2's cancel, we're just left with 14, 5 plus 9. So we have the 3 areas, so we get 2 plus 7 plus 14, which equals 23. So the distance, sorry, the area under that graph is 23, so the distance must be 23 meters. And if you check the mark scheme for this question, it's actually wrong. There's multiple errors in it. They give the height of these trapezium as some weird numbers. They give this distance as 8, not 9. They give this one as, they give this one as 5, I think, not 2. So there are multiple errors in the mark scheme for this question. The correct answer is 23. I think they got 26, which is wrong. And also for the second part, it says, is your answer an underestimate or an overestimate of the actual distance? I believe this should say overestimate, because if we look, we're always drawing these lines in above the curve. So it should be an overestimate. And the reason is the area calculated is larger than the curve. Part C says calculate an estimate for the gradient of the graph when t equals 8 seconds. You must show how you get your answer. Okay, so we need to basically draw in a tangent to the graph at t equals 8 and get the gradient of that line. So I'm going to actually have to rub all of this out, and we need a gradient at t equals 8, so that's here. Okay, so if we draw in a straight line as best we can. Okay, so if we draw in a straight line at that point, so it's just touching the graph, it should about represent the gradient of that line. And if we extend this line down, it just about goes through 0, 4. So it's going through 8, 15. So it's 15 on the y-axis and 8 on the time axis. And then it about goes through 0, 4 if I just shifted this a little bit over. And this isn't an exact thing, really, because you're just approximating. So I'm going to say it does go through 0, 4. So my rise, so then I can read my rise and my run for the gradient. So my rise there is 15, and it's gone, the run is 4 to 8. So the run there is 4. So I can say the gradient of that line is 15 over 4. So gradient equals 15 over 4 by drawing a tangent to the curve at t equals 8. And this can simplify to 3 3/4, or 3.75, however you want to write your answer. And the last part of this question says, describe fully what your answer to part C represents. Well, it's the rate of change of the speed, and we call that acceleration in meters per second and at time t, time 8 seconds. Question 16 says there are 15 boys and 9 girls in a mixed hockey team. One of the boys and one of the girls are going to be chosen to collect the cup. Work out the number of different pairs that can be chosen. So for every boy there's 9 girls, or you could say for every girl there's 15 boys. So the number of choices are 9 times 15. And 9 times 15 is 135. So the answer there is 135. And then part B says 2 of the boys are going to be chosen to play in an all-boys team. Sam thinks the number of different pairs that can be chosen is 210. Tom thinks the number of different pairs that can be chosen is 105. Who is correct, Sam or Tom? Give a reason for your answer. Now this is slightly different to part A, because in part A we had 2 different groups. We had the boys and the girls. So there were 9 times 15 pairs. But for this we have just one group, which are all boys. And so when you pair things up out of one group, you have to actually divide the number of pairs by 2. You've got 15 boys and 14 other boys they can pair up with, but you don't want to double count those pairs, so you have to divide that by 2. So 15 times 14, that is 210, but we need to divide that by 2 just so we're not pairing up the same people twice. So that's going to be 105. So in that case, Tom is correct. And you could say pairs should not be counted twice. You could also give this formula. You could say the correct calculation is 15 times 14 divided by 2. And if you're still confused as to what the difference between A and B, just try to think of this as, well, for every boy you're picking, then you've got 9 girls. They're not in the same group. They're in 2 different groups. Whereas for part B, you're choosing out of the same group. So you actually have to divide that by 2. Question 17 says the ratio of A to B equals 5 to 8 and B to C equals 6 to 25. Find in simplest form A to B to C. Okay, so we have B in this ratio equal to 8 parts and B in this ratio equal to 6 parts. And if we want to join those ratios together, we need the B part of those ratios to be the same. So we want a multiple of 6 and 8. So we want a number that both 6 and 8 go into. So 6 goes into 24 evenly and 8 goes into 24 evenly. So I can use 24 here. So for this ratio, 5 to 8, I need to multiply that by 3 to get 8 equal to 24. So if I multiply both numbers by 3, this can equal 15 to 24. So they're the same ratios. One is just multiplied by 3. And then for B to C, I've got 6 to 25, and I need to multiply that by 4. So the 6 equals 24, and so that's going to be 24 to 100. 25 times 4 is 100. And now I can say that, well, the ratio of A to B to C is going to be 15 to 24 to 100. You can see here, because the B part of that ratio is equal, I can just join those ratios together. So the ratio of A to B to C in simplest form is 15 to 24 to 100. I can't actually simplify that anymore. There's no common factors there. Question 18 says Rana wants to estimate the number of balls in a bag. On Monday, Rana removes 120 balls from the bag. She puts a mark on each ball. She then pulls all 120 balls back in the bag. On Tuesday, Rana removes 20 balls from the bag. 8 of these balls have a mark on them. Work out an estimate for the total number of balls in the bag. You must write down any assumptions you have made. Okay, so there is a bag of balls, and Rana pulls out 120 of the balls at the same time, and she puts a mark on them. And she puts them all back in the bag, and then she pulls out 20. And 8 of those balls have a mark on them. So to work out the total number of balls in the bag, we can use this fraction, 8 out of 20. And if we assume that that's the fraction of balls that she marked on Monday, then we can work out the total number of balls. So if this equals the fraction of balls marked on Monday, that will allow us to say, well, then I can work out the total number of balls. So this fraction, 8 out of 20, if we divide that by 2, we get 4 over 10. Divide by 2 again, we get 2 over 5. So 2 out of 5 of the balls were marked. So that equals 120. So if 2/5 of the balls equals 120, to work out the total number, we can work out 1/5. So if we divide both of those by 2, 1/5 will be 60 balls. So I know that 1/5 of the balls equals 60. So then, well, the total number must be 5 times 60. So 60 times 5, that equals 300. So there are 300 balls in the bag. Okay, there's a lot of assumptions we've made there. So the first assumption was that this fraction she pulled out on Tuesday represented the same fraction that she marked on Monday. So maybe we should just write those assumptions down. Assumptions. So the fraction picked on Tuesday was the same as Monday. Also, we're assuming the number of balls hasn't changed. No one's come and picked some balls out or something, so the bag stayed the same. Also, the sample was random. And also, I guess we're assuming the marks haven't worn off. So the marks haven't worn off the balls. I'm not sure you have to write all of those assumptions. I guess they do say write down any assumptions you have made. This is where I'm not sure what to recommend. I'm not sure exactly what they're looking for in terms of the answer here, so I'm sorry about that. I would suggest maybe 2 assumptions is enough, considering it's 4 marks and you've already done this working out here. So maybe write down 2 assumptions. Probably, I would say the most important one to note is that the number of balls hasn't changed and the sample was random. In other words, this fraction represents the fraction picked out on Monday as well. Question 19 says m equals 8 multiplied by 10 to the 9n, where n is an integer. Express m to the minus a third in standard form. Give your answer in terms of n as simply as possible. Okay, so the first thing to note here is anything to the minus a third. That is the same as 1 over the cubed root of that thing. So that's saying 1 divided by the cubed root of n. So you should be aware of that from your index laws. So we can say that m to the minus a third will be 1 over the cube root of all of this. So 8 times 10 to the 9n. Okay, so all I've done is taken the cube root of that and written it as a fraction. So now this is the same as if I take the cube root of 2 things multiplied, so 8 times whatever this is, so 10 to the 9n, that will be the same as the cube root of each thing separately. So that's perfectly fine to split them up like that. So that's part of surds. So this whole question is really about surds and rules of surds. So if we split them up like that, well, the cube root of 8 is 2. And the cube root of this, well, because it's to the power of 9, you could write this as the cube root of 10 cubed, and then you could put that all to the power of 3n. So I've split that 9n up into 3 times 3n. So that would be the same thing there. So the cube root of 10 cubed is just 10. So what we end up with here on the next line is 1 divided by 2 multiplied by 10 to the 3n. So I've got rid of that cube root by finding the cube root of 8 and cancelling this cube root with 10 cubed. So my next line is 1 divided by 2 times 10 to the 3n. And we can split that up into a half multiplied by 1 over 10 to the 3n. Okay, so I've just split that fraction up into 2 pieces. Okay, another way to write this, if we're thinking about our standard form, Well, this half could be written as 0.5 times 10 to the minus 3n. 1 over anything can be written as a negative exponent. And now, to be in standard form, this first number needs to be between 1 and 10. So I can change this to 5 by dividing by 10. And then I still have that multiplied by minus 3n. Now, rather than dividing this 5 by 10, I can divide this by 10. So this can be written as 5 multiplied by 10 to the minus 3n divided by 10. So all I've done there is rearrange this slightly. I haven't changed anything. And now if you have the same base number, so if we had, say, 2 to the 5 divided by 2 to the 3, think for a second, what would you do with those exponents? You would subtract them. So you'd do 5 subtract 3 to get the answer. So the answer here would be 2 squared. So we can do the same thing here. So this is like 10 to the power of 1. So we've got, what we can say is this will equal 5 times 10 to the minus 3n minus 1. Okay, so I've just subtracted those exponents there because I have the same base number. So I can say, after all of that, m to the minus a third equals 5 times 10 to the minus 3n minus 1. Question 20 gives us a diagram of 6 coins, and it says, Ashok has 6 coins in his pocket. He has 1 5-cent coin, 2 10-cent coins, and 3 20-cent coins. He takes at random a coin from his pocket. He records its value and puts the coin back into his pocket. He then takes at random a second coin from his pocket and records its value. Calculate the probability that he takes 2 20-cent coins. Okay, so we can write that as P, standing for probability of 20 cent and 20 cents. So I've just basically written that sentence in a shorter form. And well, by the way, I don't know why they're using cents. Why they're not using pence? But anyway, so the probability of picking one 20-cent coin, well, that's there's 3 20-cent coins out of 6 coins. So the probability of picking one 20-cent coin would be 3 out of 6. And then picking another 20-cent coin, because he puts it back into his pocket, so he's replacing the coin, it will be the same again. So this is going to be 3 over 6 again. And we multiply them because they are 2 independent events. They're not affecting each other. Okay, so this is the same. 3 over 6 is the same as a half. So you could just say a half times a half. Half multiplied by a half, and that's a quarter. So the probability of picking a 20-cent coin, putting it back in his pocket and picking another 20-cent coin is a quarter. And then part B says calculate the probability that the second coin he takes has a higher value than the first coin he takes. Okay, so what are all the possible ways of doing this? Well, if he picks a 5-cent coin, he could get a 10-cent or a 20-cent. So that's the first probability. I could pick a 5-cent and then a 10-cent coin. Or I could pick a 5-cent and then a 20-cent coin. Okay, so that's if I pick a 5-cent coin first. And if I picked a 10-cent coin, then I could only pick a 20-cent coin because it says the second coin needs a higher value. Not the same or higher, it only says higher. So the only other possibility is I pick a 10-cent and a 20-cent. So we need to work out the probability of all of these occurring. So the probability of picking a 5-cent and then a 10-cent. A 5-cent coin is 1 out of 6. And picking a 10-cent is 2 out of 6, or a third. Okay, so 1 out of 6 multiplied by 1/3 is 1 over 18. Then picking a 5-cent and then a 20-cent, well, that's going to be 1 out of 6 again, multiplied by 3 over 6, or a half. So that's going to be 1/12. And then the probability of picking a 10-cent coin, then a 20-cent coin, well, there's 2 10-cent coins. So again, that's 2 out of 6, or 1/3. multiplied by the probability of picking a 20-cent coin, which was a half, as we said before. So a third times a half, that's a sixth. And so we have the probability of all of these three things occurring. And because we want the probability of a 5-cent and a 10-cent, or a 5-cent and a 20-cent, or a 10-cent and a 20-cent, so we're saying this could happen, or this could happen, or this could happen, we add those together. So we've got 1/18th plus 1/12th plus 1/6. And we just need to change the denominators so they all have the same denominator, then we can add them together. So the lowest common denominator here is 36. 18 goes into 36, 12 goes into 36, and 6 goes into 36. So if we multiply 18 by 2, we get 36, plus 12 times 3 is 36, so it's going to be 3 over 36, and then 1/6 out of 36. Well, think of your equivalent fractions. I need to multiply that by 6. So I've just converted all those fractions so that they have the same denominator, then I can add them together. So 2 plus 3 plus 6, that's going to be 11 out of 36, and that's my answer. Okay, so you had to work out the probability of the three different events happening and then add them together. And that was the last question of this paper. I hope you found this useful. Please leave a like if you did. I'll have paper 3 up hopefully by tomorrow. And subscribe if you want to see more content. Thanks for watching. I'll see you next time. Bye for now.